Alright everyone, welcome to the 4.3 video. I pulled up the homework. We don't want the homework, we want the lesson. So give me a second. Switch that over. Okay, so this is a graphing calculator based notes. So it's really important right now that you have your notes out because you're not going to be able to watch the video without the notes out because I am not going to be able to show the notes and the graphing calculator at the same time. So these are what the notes should look like. All right, so let's just go through some of the important information that you need to know about the notes before we jump into the graphing calculator stuff. So the degree of a function is also the maximum number of zeros that the polynomial function can have. The relative maximum is a turning point on the graph of the polynomial function where the function changes from increase to decrease. And relative minimum is a turning point on the graph of the polynomial function where the function changes from decrease to increase. So that's the difference between the two. Absolute max and min is the absolute lowest or highest point on the graph. Now, any odd degree polynomial will not have an absolute max or min, and an even degree will have one or the other. It can't have both an absolute max and a min because it's going to be going in one direction infinitely, right? A turning point is a point at which the graph turns at the location of a relative min or max. And repeated roots, a polynomial can have double roots, triple roots, quadruple roots, and so on. In general, these are referred to as multiple roots. So even, bounces, odd, cross. So we'll talk about how you can see the difference between those different scenarios. Okay, so example 1, analyzing graphs of polynomial functions with the graphing calculator. So step 1 is you're going to type it into the graphing calculator, adjust the viewing window. We always give you the information about what to adjust it. And then we're going to trace to find the zeros and all sorts of other information. So let's go ahead and do that with the graphing calculator. So I go to y equals, and I'm going to type in my function. And second power plus, oh, it's actually third power. Oops. So it should be a 3. And then we have plus x squared. So I know a bunch of you guys are going to ask me, how did I get the 3 power here? So there's 2 ways to do it, really. You can type in 2 and then arrow back over and change it into a 3. Or there's this button right here on the calculator that looks like a little, it's called a caret. Okay, it's like an upside down V. You can hit that, and that will give you a power. Okay, so like minus 5x is the next one. Now, if I wanted to put a power on that, I could hit that button. See how it gives me the chance to type up there. We don't want it right now, though, but that's how you can do it. So then I'm going to adjust the viewing window. So I click Window, and we always give you the information on what your window should look like on the note. So go ahead and type it in accordingly. So -5. The next one should be 5, and then 1, -5. 5, and the other 2 are 1. So then you're going to click Graph, and it should look something like this. Now, we want to find the zeros. So to find the zeros, we're going to use the Trace button. You remember this from when we did quadratics. So I see I have a 0 at 0, 0. So you're going to go ahead and write that down, a 0 at 0, 0. And then we can arrow over. Oops, where did I go? I went a little too far, huh? It looks like I also have a 0 at let's see. Oh, even better. Second trace, we can go to calculate a 0. Instead of actually tracing the 0 out, we can do second trace and actually use an operation that will get us the 0. So we already found that one. We want to do our left bound. It's asking for a left bound. So enter and right bound. So it looks like we have a 0 at about 1. And we also have one at about negative 1.5. So you're going to go ahead and write those both down at 1 and 1.1-ish and negative 1.5. Okay. So now we're going to calculate our relative max and relative min. So you're going to hit second calc or second trace, which is calc. And then we want to calculate our maximum and minimum. So let's do the maximum first. So we want our left bound. And then our right bound. That's not right. Okay. So let's see. Try it again. Sometimes it doesn't work right. So let's try maximum. Enter. And I think with bounds, it wants you to go to where it touches the x-axis at those boundaries. Let's try that instead. So about here. And my right bound is about here. Yeah, that works much better. Okay, sorry about that. So when you go to do the boundaries, you're going to hit left bound is like where we touch the x-axis before we get to the max, and then where we touch the x-axis after we get to the max. Okay, so that'll work. So your maximum is at about 3. You can type that in as a coordinate there. And then we're going to look at the minimum. So let's go to second calc. We're going to try minimum. And then we're going to do our 2 boundaries. So left boundary, we're going to use the x-intercepts that surround that. And then we have another one over here, our right bound. So it looks like we have a minimum at -2. So 0.6 comma -2. And then we're going to find, well, we already know the y-intercept is 0, 0, right? Because we already calculated that. It's an x-intercept and a y-intercept. Number of turning points, you can determine this just by looking at the graph. There are 2 turning points. The degree of the polynomial is 3 because it's always 1 more than the number of turning points. And then the end behavior. So as x goes to negative infinity, as we go to negative infinity, my function goes down. So as x goes to negative infinity, my function also goes to negative infinity. So talking about this, your function is going to negative infinity. As my function goes to the left, or I'm sorry, to the right, my function goes to positive infinity, upward direction, okay? And then number of real zeros, it looks like we have 1, 2, 3 real zeros, which means we must have 0 imaginary zeros. Both domain and range are negative infinity to positive infinity. And the number of turning points, we already said, was 2. So increase, decrease intervals, those are going to be based on the max and the min. So we're, whatever we calculated for max and min, we're increasing from negative infinity until we get to that x-coordinate of our maximum, whatever that was. I don't remember what it was. And then from the x-coordinate of our maximum to the x-coordinate of our minimum is where we're decreasing. So from whatever this x value is until we get to about 0.6. And then from 0.6 to positive infinity, we're increasing again. Leading coefficient, this ends upward, so my leading coefficient has to be positive. So classifying the polynomial name, this would be a cubic polynomial. Okay, so let's do another one together. So I'm going to go ahead and clear my calculator out. Okay, so I go to y equals, and I'm going to type in example 2. I was trying to see if it would work with the keyboard, but it doesn't. This is x minus 1 squared times x plus 4. I'm going to go to my window and adjust it, just as the paper will tell you what to type in. Okay. I'm going to hit graph, and you're going to get something that looks like this, so you can go ahead and sketch that. Okay. Let's see. So I think we have a little bit of a typo on our notes. So this should say what this is, okay? I don't know why it says the old function there. You're just going to go ahead and change that, okay? So change that to this. Sorry about that. All right, so let's go ahead and look at the zeros. So we're going to hit second calc, and we're going to type in 0. And then we're going to find the left and the right boundary of that. So it's a little hard to see up here. So I'm going to say from here, we want a 0 between here and between here. We're going to see if it works. Sometimes you have to trial and error with these calculators. Where did it go? Oops, didn't work. Okay. Let's see. Second calc, we're going to go to 0. And then we need our left bound. Let's try this. And our right bound. Okay, so you just want to find some equidistant points on each side. Sometimes when you go too high, it doesn't work. So sometimes you have to trial and error. Looks like we have a 0 at 1, 0. Okay, and then we also want to find the 0 over here as well. So you have a few different options to do that. We can just try to trace it and see if we can find it. So it's somewhere between, it looks like it's at x equals -4. So we can trace it to find it, or you can use the actual operation to find it, whatever one works for you. That's 2 options to do it. Now we're going to find relative max and relative min. So we go to second calc, we go to maximum. So we want to find a left boundary, and then we're going to find a right boundary. Okay, so it looks like we have a maximum at about -2.3 repeating, and then we have one at about 18.5. So -2.3 repeating and 18.5 is our max. So you want to write that down on the line for maximum. Now we're going to go ahead and find our relative minimum. So you're going to go to second calc, and you're going to go to minimum, and then you're going to find the boundaries. We're going to use this as our left bound, and then I need a right bound. And like I said, sometimes it doesn't work out nicely with the boundaries that you pick, so you have to play around with it a little bit until you get one that works. Okay, so we have a minimum at about 1, 1.3. Okay. So now we want to figure out the degree of this polynomial. Well, there's 2 turning points, right? Which means the degree is 3. And behavior. So as this graph goes to the negative infinity direction for x, it's going downward, right? Downward right here. Okay, so negative infinity. And as it goes to the positive direction for x, it's going upward. So it's going to be negative infinity and then positive infinity. Number of real zeros, we have 1 0 here. And then remember, we talked about this yesterday. We actually have 2 zeros here. So let's talk a little bit about how that's the case. This bounces, which indicates that that 0 occurs twice. If you look at the actual equation of this thing, okay, see how the 0 of 1 occurs twice, it's squared. Okay, so there actually are no imaginary zeros here. This 0 is just occurring twice, which causes it to look a little different on the graph. It's actually going to bounce here instead of going through like it would if it only occurred once. Domain and range are both negative infinity to positive infinity. And the y-intercept, we can trace to find that. I don't know if there is an operation for that one. No, I don't think there is. Okay, so we're just going to go to trace. And we have one at 0, 4. And then increase, decrease intervals are, of course, based on the maximum and the minimum. So it looks like we're increasing from negative infinity until we get to the maximum at about negative 2.3. So from negative infinity to negative 2.3, we're increasing. And then we're decreasing from negative 2.3 until we get to the minimum, which is at 1. So from negative 2.3 to 1, we're decreasing. And then from 1 to positive infinity, we're increasing again. So if you don't remember what those values were, you can go back and kind of trace over them to remember. Or, well, you have it written down on your paper. So see how from 1 to positive infinity, we're increasing. Because that's where those numbers are coming from. And then the leading coefficient, it ends upward, which means my leading coefficient has to be positive. And this is a cubic polynomial because it's a third degree. Okay. So now we're going to look at analyzing graphs of the polynomial in context. Okay. So for this one, I am going to be able to use the inner so give me a second. All right, so I went ahead and cleared my calculator out, so I'm ready to type in the equation, which is right here. So it is 0.015 x to the 4th power. And then when you're at the 4 up there, make sure you put this arrow button so you come back down from being on the exponent. Minus 0.44 x power of 3. Just typing in the equation. And then plus 3 oops, that's not what I wanted. Go back and delete like that. 3.46 x to the 2nd power minus 2.5 x plus 9.68. So this is a long equation, so just double, triple check that you typed it in right. You don't want to have more problems down the road when you make a mistake. Hit window and change your window to what it should be. Okay, so we get here, and then we can hit graph. It should look something like this. Okay, so I'm going to pull this to the side for a second. You have it on your calculator so we can look at the questions. So it says sketch and label a graph with the model that will model this problem. Okay, so go ahead and sketch that. So it looks like if I want to sketch this, I'm going to have to figure out what this value is at. It looks like it's at about 2. I'm going to go ahead and hit trace. I'm going to go over here and make sure. So it looks like it's at, because we changed our boundaries and stuff, we changed our scale. So it's at about 9.68, so about 10. Starts at about 10. Of course, this is our actual, that's our starting point, our y-intercept. So let's say that we go by like tens. So 10, 20, and so on. So this is about our y-intercept. And then if we go ahead and trace, sorry, it's so hard with two different things going on one screen and trying to drag it over. If we go here, we can see that we have a relative max at about 46, 45, 46. So that's at 30, 40, and 50. So at 7, we'll go by ones here. Maybe we shouldn't go by ones. Let's see what fits. See what our minimum is to see what scale we should go by. Okay, so it's going to go to about 14, so we want to make sure we can fit 14. So maybe let's go by 2s instead. Okay. So like I said, we have a relative max at about 45, about 7, between 7 and 8. So like here at 45, and then we have a minimum over here at 13, at about 20, and then we go up from there. So it's going to look something like this. And the thing about this is not one of those kind of lessons or things where everything's going to be exact and it's going to work out the first time and you don't have to go and adjust anything. This is, this is the type of math that is where you have to go back and adjust and see what works. So trial and error. What was the initial number of pagers in 1990? So let's see. Where X is the number of years after 1990. So this is X and this is Y. So this is the number of years after 1990. So what was the initial number of pagers in 1990? Well, this right here, 0, represents 1990. So initially there were 9.68 pagers. So kind of weird. And this is in millions. So 9.68 million pagers. Describe the end behavior of this graph. As X goes to negative infinity, Y, it stays at 6.8 and 9.68 because we're not ever going to go past this. We're not ever going this way. This is a hard boundary on the graph, okay? We're not ever going to infinity on that direction. And then as X goes to, so really this is like saying, we could also say 0. So I know you haven't seen this before, but you could also change this to 0. As X approaches 0, so as we get close to 0 on the graph, like this, my graph gets closer and closer to 9.8. And then as X goes to positive infinity, my function goes up to positive infinity. What does the end behavior suggest about the number of pager subscribers in the US? Increasing after, consistently. After about here. So that's at about 14. So 1994 plus, or 1990 plus 14, which would be 2004. Okay. So we have that. That should have been here, not there, sorry. And then will this trend continue indefinitely? Maybe, But let's think about what we know. Do pagers still exist right now? Unless they're converting this into cell phones, of course, like converting this data into cell phone data. Most likely not, right? because we're only looking at a small glimpse of this. This right here is a positive end behavior function. So theoretically, yes, but we don't know for sure. So here's the thing. We know with this particular equation it will, but we don't know if this data will always follow this model. Okay, this model could be, expired model. All right. So that's that. I know this one is a little bit difficult because of all the different screens and whatnot and all the trials and everything. So just try your best. Make sure you're following along with the graphing calculator. And I know you guys can do it.